In these last two examples, we're going to go through the same process, just give you a couple more examples of simplifying these trigonometric expressions. The first one, I've got some negative theta angles. I also have a fraction with some tangents in it. So I guess the first thing I would think of is to rewrite these in terms of, I guess it says rewrite them in terms of the sine and the cosine. Maybe I'll leave the negative in there and we'll deal with the negative. Actually, you know what? Let's get rid of the negatives. Why not? You can do this either way. Sometimes getting rid of those negatives on the inside is nicer. Now the tangent, remember, is an odd function. And so the tangent of negative theta is the same as the negative tangent of theta, okay? So I would write it this way, 1 minus the tangent of theta, right? So tangent of negative theta is a negative tangent of theta over the negative tangent of theta. So that's using an odd identity. Okay, one of our odd-even identities, okay? Then we're going to rewrite them in terms of sine and cosine. So the tangent becomes the sine over the cosine. And here, this tangent also becomes a sine over the cosine. So that's using a quotient identity. Okay, now because we're running out of room, I'm going to invade the space on the other one there, so we'll keep that one separated and come back to it. I'll erase what I need to. Okay, so here I've got a difference up on top, 1 minus a fraction. To combine those, I'm going to need to get a common denominator. So this 1 should really be cosine over cosine, right? Anything divided by itself is 1, and I want the cosine on the bottom. So I'm going to rewrite that. Let's bring it up here. We're going to rewrite it as the cosine of theta over the cosine of theta. That's my 1, minus the sine of theta over the cosine of theta. All right, so that's my numerator. And give myself a little more room there. Okay, and then I have a negative sine theta over cosine of theta on the bottom. Okay, and of course that's done using, getting an LCD. I'm not going to write out the, we'll just say LCD there. Okay, that's the rationale. Okay, so here I'm subtracting two fractions. I can get them together now that they have an LCD. I can call it cosine minus sine on top. Cosine theta minus sine theta all over the cosine of theta. Okay, so I just combine two fractions into one. And on the bottom I still have a negative sine theta over the cosine of theta. All right. Next thing I might do is to multiply by the reciprocal, correct? So I've got a fraction over a fraction. Let's do that. Let's go cosine theta minus sine theta all over the cosine of theta times the reciprocal of that, which is negative cosine theta all over the sine of theta. Technically, I should throw that in parentheses because of the negative in there. It gets a little confusing what's going on. I can cancel the cosines. That's kind of nice. That'll work. And then I can bring this sine underneath. I can combine the two fractions together essentially. And I'm going to get the cosine of theta minus the sine of theta all over. I'm going to keep this negative with the sine of theta. I guess it doesn't really matter. If I wanted to, I could distribute the negative to the top even. I could call it negative cosine plus the sine. Change the signs up top. That may be ideal. We'll continue from here. Let's look at, you know what? Next thing I might want to do, I want to get rid of fractions. So let's split this fraction up. Let's put the sign on the bottom of each of these terms here. So So let's go with the cosine of theta over the negative sine of theta minus the sine of theta over the negative sine of theta. Interesting. Here, cosine over sine we know to be the cotangent, right? So I'm going to write that as the cotangent of theta, but it also has a negative, so it's really the negative cotangent of theta. And here the double negative makes for a plus. Sine over sine is 1. Anything over itself is 1. And so that's using, I should put an identity in here. A lot of this stuff was just sort of algebra that I was doing, so I didn't put my rationale, but you could put things like combining fractions with a common denominator, canceling, multiply by reciprocal. Those sorts of notes could be important there. Here, what I used was a quotient identity. And then finally, I might rewrite this so that I don't have this negative hanging out in front. If I interchange the terms, I could write that as 1 minus the cotangent of theta. And that's probably as simple as it gets. All right. So there's no fractions, there's no negatives. There's no negatives in the argument or in the angle, right? It's an angle of theta only, not negative theta. Okay, so that works out pretty nicely. So let's work on this next problem here. Get rid of some of this one, the first one. Give myself a little space, and if I need to erase more, I can. Okay, so here again it says rewrite everything in terms of sine and cosine and simplify. So I've got sine and cosine, but I also have cosecant and secant. So let's rewrite those two using our reciprocal identities. Whenever I see cosecant and secant, I think right to the reciprocal identity. So cosecant is 1 over the sine, and the secant is 1 over the cosine. Okay. From there, I don't know, there's not much I can do inside these parentheses. I can't really combine any of these things. Could try to get a common denominator here, but I think I prefer to do something else instead. I'll show you what I'm going to do instead. I'm going to use a distributive property to multiply these together, right? First term times first term, and keep going, use our distributive property here. So sine times 1 over sine is the sine over the sine, right? So that times that is here. I got sine times 1 over the cosine, which is the sine over the cosine. Then I've got negative cosine times 1 over the sine is a negative cosine over sine. And then I've got negative cosine times 1 over the cosine is a negative cosine over cosine. Right, so that gives me, it's kind of like the FOIL method, if you guys remember that. I hate using that term because it doesn't work when you have more than 2 terms, but it works here, FOIL, right, when you multiply those together. I can simplify each of my fractions then. I've got the sine over the sine is 1. I've got the cosine over the cosine, that's a minus 1. Sine over cosine is the tangent, so plus tangent. And cosine over sine is the cotangent, so it's minus a cotangent. I should probably put the identities, make note of these. This was the reciprocal identities. I'll write it all out. Reciprocal identities. Then I just multiplied. Here I'm using both the quotient and reciprocal identity. No, I'm sorry. Just quotient identities right there in the middle, and everything else was canceling. So I'll say quotient identities there. Okay. And then I've got 1 minus 1, which is 0. Those cancel out. And I'm left with simply the tangent theta minus the cotangent of theta. Doesn't really get any simpler than that. There's no fractions involved, there's no negatives in the angle, and everything's really combined as tightly as possible. So that would be a good simplified expression. So we've created now a new identity that says the sine minus the cosine times the cosecant plus the secant is equal to the tangent minus the cotangent. Again, these two expressions will be equal to each other.